So we're going to sketch the graph for this function. We're going to follow these 3 steps over here, apply the leading coefficient test, find the zeros and multiplicities, and then we're going to plot additional points. So here is my function over here. My leading coefficient is negative 2x to the third. So it is negative and it is odd. So my graph is going to look like some sort of cubic function. And so, leading coefficient test says as x approaches negative infinity, f of x is going up to positive infinity. As x approaches positive infinity, f of x is going towards negative infinity. And so you can think about that like a parent function, cubic function reflected over the x-axis, not y, x-axis. So there's your leading coefficient test. Next thing we're going to do is find the zeros and the multiplicity. So if I've got my function, I'm going to see if I can factor it. So crazy thing here is this fraction over here. So how do I get rid of that? How do I fix that so that it's not as tricky later on? Well, you can think about it a couple of different ways. You can multiply everything by 2. But then that kind of is counterproductive because we're taking out a GCF, we're factoring it, we're getting it as simplified as possible. You can also take out a 9/2. That would be helpful. But then you might deal with some fractions elsewhere. You could also just take out a 1/2. And so that's actually the route that I'm going to take. So I'm going to take out a 1/2 x. When I take out a 1/2 x, that means that my leading coefficient, I'm actually going to take out a negative 1/2 x since my leading term is negative. So in here, I'm going to have a positive 4x squared, negative 1/2 x times 4x squared gives me negative 2x cubed. Negative 1/2 x times a negative 12x gives me positive 6x squared, and a negative 1/2 times a positive 9 gives me 9/2 x. So initially it's kind of tricky, but once we take care of that, it should be pretty good to go. My leading coefficient is 4. I've got a trinomial in the parentheses, so I'm going to factor it like a regular trinomial. I need 2 numbers that multiply to give me 36, but add to give me negative 12. It's negative 6 and negative 6. Keeping that GCF on the outside, I'm going to go ahead and write my trinomial as a polynomial so I can factor it by grouping. If you have learned how to factor a trinomial where a is greater than 1 a different way, go for it. It doesn't have to be the exact same way. There's lots of processes out there. Between 4x squared and 6x, I can take out a 2x. That leaves me with 2x minus 3. Negative 6x and 9, take out a negative 3. Leaves me with 2x minus 3. Got some good things going on. My stuff in parentheses matches. And so finally, my final answer is negative 1/2 x times 2x minus 3 times 2x minus 3. If we simplify that a little bit further, since 2x minus 3 repeats, we can just put it raised to the power of 2. And so we factored it. To find our zeros, we're going to set all those factors equal to 0. Remember, it qualifies as a factor if it has an x. So even though initially my negative 1/2 x was a GCF, because it has an x, it's a factor. So we're going to set negative 1/2 x equal to 0 and 2x minus 3 equal to 0. So when we solve, multiply both sides by negative 2, we find that x is 0. And then over here, add 3 to both sides, divide both sides by 2, we find that x is 3/2. So then we think about x being 0 and its multiplicity. So if we go over to where we factored it, negative 1/2 x has an exponent of 1. It occurs 1 time. That's an odd multiplicity, which means it crosses the x-axis at 0. 3/2 had a factor of 2x minus 3 squared. It occurred twice, so it has an even multiplicity, and it touches or bounces across the x-axis. So, time to sketch it. My end behavior is up, down. I know it crosses at 0, and it touches, let me add some more in there, at 1.5. So you kind of have to think about it, think ahead, be able to visualize. And so I know it crosses at 0, has to turn around somewhere to come up and touch at 1.5 and then go back down. Still has the shape of a cubic function. So your graph should look something like that. It's a little imperfect, but generally that's what it should look like. Always check with Desmos to make sure that you are on the right track.